Good afternoon, everyone. So, in today's lesson, we are just going to be tackling what probability is. And for us to basically know what probability is, we need to know a few terms. That is basically defining certain terms that will lead us on to knowing what probability is. So, let's just get straight into today's business. So, in terms of giving definition to what probability is, we need to take note of the fact that you need to know what an experiment is. We also need to touch base on what an event is. These are the words or terms that you'll be seeing more frequent than ever. You also need to know what an outcome is, and that even comes in twos to say that we've got just the general outcome and then we've got equally likely outcomes. Then, since probability touches base on sets or the set theory, there are certain words that we also need to know that speaks to your sample space. In other words, that is also known as the universal set, but I'll get into more detail when we are now speaking to them as individual terms. So you also need to know what a sample point is, what is an event space. This touches base on another terminology that you also know from your set theory, which speaks to the subset of a sample space, which is what we're going to be naming here an event space. Then last but not least, you also need to know what mutually exclusive events and what mutually inclusive events are. Well, now that we know the expectations of today's lesson, let us just get started. So for a start, let's give a definition as to what an experiment is. So this word, when it's taken from the mathematics side of life, you will note that it is a process that we use to generate numeric values or numeric data that are later on used for analysis. But in probability, note that your experiments are going to be split into two groups, mainly deterministic and the random experiment. So to explain further what a deterministic experiment is, it is whereby the results of the experiment are not subject to chance if repeated severally under the same conditions. Maybe to give an example on that, I can say when you are trying to measure the length of a particular straight line, that is meant to give you the same results always, because I'm thinking that if you are to be using a ruler that's already standardized, hence you should always be having the same results through and through. Then for a random experiment, this is when the results are always subject to chances. That is to say, it is never going to give you the same result through and through. And if I'm to give an example, we can say when you are tossing a fair coin, when you're gambling, when you're down there in the casino, when you're voting, there is no way you are going to be getting the same figures as always. So, those are the two that you now need to know with regards to an experiment. So always note that there is a deterministic experiment and there is also a random experiment. Then moving on to the next definition, which is an event. We'll follow through from what has been written there. That is possible outcomes of a trial or an experiment. And these are usually denoted in capital letters. So if I am to touch base on the first example that we mentioned, we said when you're tossing a coin, my outcome can either be head or tail. So if I am describing that event, I can say event A, it is me just tossing a coin. Then the next term to describe, it is an outcome. So an outcome, it is the result of any experiment that is carried under well-defined conditions. Yeah. It just has to be under well-defined conditions. For example, if you are to toss a coin and head shows up, head is the outcome of the experiment that you have just carried out. Then someone will be like, so what is the difference between an outcome and equally likely outcomes? Take note that equally likely outcomes, they usually occur when the outcomes have got an equal chance of occurring. For example, we all know that a coin has got two sides. So if I am to say, toss the coin up, what's the probability of me getting a head or getting a tail? Due to the fact that we only have two sides, it means half as me getting the probability of getting a head and the other one that of getting a tail. So That means to say that the head and the tail of a fair the head and the tail of a fair coin, I don't know why I'm speaking of a die, of a fair coin are equally likely outcomes of an experiment. So when I toss a coin, we have equal chances of both outcomes to occur. Maybe if I'm to give another experiment politically, we can say that one candidate for a post is equally likely to be elected just like the other. So you can either win or you can lose. So there's an equal chance that I might be a minister of, I have no idea, politically. So those are the two differences. So not that they are just your basic outcomes, which is just the result of any experiment that is being carried out. And then we have equally likely, we know that whenever I am getting into this experiment or it's a competition, there is an equal fair chance that I can make it as well as my opponent. So those are the two differences that you need to note for a basic outcome and an equally likely event. Okay, as a continuation, just moving on to the next definition of what a sample space is. Not that a sample space of a random experiment. This is just a random experiment. It is actually the collection or a set of all possible distinct outcomes of the experiment. Just like I mentioned before, like in the introduction, when I was just setting out the things that we're going to be roughly discussing today, I did note that in set theory, a sample space is also called a universal set. So if it's a universal set, now you are saying that if I am to throw a coin or to toss a coin, what is my sample space? My sample space is, it's possible that I can get a head and I can get a tail. So it means my H for the head and my T for the tail. Those are the two items that I'm going to put inside the curly brackets to denote a sample space. Then another example, I think that's the one that you can definitely see there, that this is a political one, to say that these are contestants or candidates that want to be elected in some party. And we have just 4 people. That is going to be Mr. Dlamini, Mr. Shongwe, Mr. Thabetse, and Mr. Spanze. So these 4 people, they are the only distinct outcome of the experiment. There is no way we can wake up and have a Miss Madlala being elected when she wasn't even there as part of the collection or the set of the possible outcomes of the experiment. In other words, there is no way I can be elected if I'm not part of the sample space. So these are things that you need to note. And then when we have already defined I think if you just take back to down memory lane to maybe when you're doing Form 1, Form 2 as an introduction to sets, I think someone did explain to you that we've got what is called a universal set, which was denoted as that Cayley signal. I think we'll get to note it down in our first lesson to be writing all those things down. You know that this is everyone that is participating in that experiment. So that, in other words, is what your sample space is. Then moving on, you need to also know what a sample point. Well, now that you know what a sample space is, a sample point is basically that single point or element that is in the sample space. So in this case, if I'm to go back to those 4 candidates, you can note that there was a Dlamini, a Shongwe, Thabetse, and Spanze. So we can say if I am to choose any of those 4 at random, that is now speaking to a sample point. And it's denoted by your N bracket S, and we close the bracket. Then I believe there are no questions for now. So moving on to the next, you need to also know what an event space is. So an event space is also known as a subset of a sample space. So if it's a subset, we are now saying that we have to be removing those distinct properties and features that are speaking collectively to the sample points. That is to say, in our first example, I think we'll just go back to that of tossing a coin. If I am to toss a coin, we say the sample space, it's either I can get a head or I can get a tail. But if I am to do an event space, it means that 1, it has to always be denoted as my 2 raised to the power of n. The power of n, that n now speaks to the number of items that are there in our sample space. So in this example, when I'm tossing a coin, how many items are inside our sample space? We've got 2. Therefore, 2 raised to the power of 2, I'm getting 4. It means my event space, it should be having 4 items. The first being a head, second being a tail, the third is a head and a tail, and lastly it's an empty set. So those are the 4 items that I'm getting, or rather those are the 4 subsets of my sample space. So maybe if I'm to give another example, we can say that if I am rolling a die has got 6 sides. So if I am to roll that and say, give me give me a sample space of a die, it means you're just going to note down the numbers from 1 to 6. But if I'm to say, give me an event space, it means it's now 2 raised to the power of 6. The answer to that, it is the number of the event spaces that you're going to be giving out. Lastly, in this slide, we are having what is known as a complementary event. So these are the 2 outcomes of an event that are the only 2 possible outcomes. If I flip a coin, I can either get a head or I can get a tail. So if someone gets a head, complementary, that means it's the complementary of the tail. If I am to get a tail, if I'm to explain why I got a tail, I'm just saying that it is the complement of a what? Of a head. So those are the complementary events. Well, now that we are almost done, I think these are the just last 2 definitions that we need to give. So there is a difference between a mutually exclusive event and a mutually inclusive event. So for a mutually exclusive events, just take note of the fact that these are 2 events that can't happen at the same time. Maybe just to pause there. Suppose you're carrying a pen or using your right hand or left hand if you're left-handed. Try to draw a circle moving clockwise, in a clockwise direction. That is pretty simple for me to do. What is to do in that? Using your right foot, can you try and draw your clockwise circle using it? So it means my right hand side is moving in a clockwise direction, whilst my right foot is also drawing a circle on the floor in a clockwise direction. That is pretty simple to do. But stop there and now say, using my hand, I will move in a clockwise direction, but my feet is going to be moving in an anti-clockwise direction. 2 minutes, the brain is like, girl, what are you doing? Or guy, what are you doing? Because you are going to confuse yourself, but you have to do it slowly for you to be in a position to do it. So whenever we say events that are happening, that can't happen rather at the same time, this is always referred to mutually exclusive events. If we're to take it to sets, it means I'll be just drawing a circle for event A and drawing another circle for event B. These 2 circles, they have no intersection in the middle. Whilst on the other hand, your mutually inclusive events, we are saying that these 2 events can happen simultaneously in a single tribe. So if they can happen at the same time, I now have to give you an example of playing cards. Whilst we're still on that, you need to also know how many cards are there in a pack of cards. What are the colors? What are the symbols? Because that is taken to be general knowledge whenever we're dealing with probability. So it means I can get a red card that is also a king. So there is an event for red cards. There is also an event for kings. So if I can get the 2, basically if I can get something in my intersect section, that is speaking to mutually exclusive events. I believe that is pretty much simple. All right, so now that we have done a bit today, we have given definitions to certain terminologies that you need to get familiar with in probability. We can safely say what probability is. So one short thing that you need to note is the probability of an event. I can denote that and say A, capital letter. happening or occurring is the measurement of the possibility of that event occurring in any one trial or experiment carried under a defined conditions. If you did not get that, what I am simply saying is probability is equal to your favorable outcome divided by the total outcomes. That says that to all probabilities, we usually denote or give them out as a fraction. So there is always my denominator, which is the total outcomes, total sample space, and the favorable outcome is whatever it is that you're being asked to find. Hence, from the definitions that we've been given up there, I believe you can now state and now know what probability is. But if ever you do have questions with regards to everything that we have done, please do take your pen and paper, write down the question, post it under this video if you are on YouTube. If it's going to be on Moodle, we're going to open a discussion session where you're going to be putting all the comments and discussions under it. Okay, so we just need to see if people did understand or grasp something new from the stuff that we've done today. So just take the time to pause and try those questions. These are pretty simple. I'm sure a Form 1 student can even attempt them. So we're saying in a case of a rolling die, what is the probability of getting an even number, of getting a prime number, not an even number, and a number greater than 4? Take note of the fact that you need to be knowing what an even number is, what is a prime number, and what does it mean to say a number greater than. So if all those are the definitions that you do have, do match them together with the ones that we did today. And then the solutions to those, I believe our next video or our next lesson is going to tackle everything from there. So now let's take down memory lane as to what we did and covered today. Please do take note of the first thing. What is probability? You need to know the definition of it. And then we did speak about experiments. Experiments, we say they're classified into two groups. That is the deterministic and the random experiment. What are the differences between the two? And then lastly, you also need to recap on why are we doing probability? As much as it wasn't discussed today, but why are we doing this? I'm sure from the examples that I gave today, you are already seeing the benefit and the uses of probability in our day-to-day life. So with that being said, not that for today we are done, but in the next lesson, we are going to tackle your exams of probability. These are the rules and regulations. What am I supposed to do when I'm calculating a probability? There are rules that I need to stick to, but we will explain that in detail in our next lesson. If there are no questions, I think we'll see each other in the next lesson. Thank you.